Hello students, welcome to Nelson's Primary School's online education program. Standard 6, Subject Science, Chapter number 13, Fun with Magnet. Students, you must have observed that if you leave the door of a refrigerator slightly open, it shuts down automatically. Do you know why? It happens due to the magnetic door closer fitted inside the refrigerator. Many cupboard doors and flaps of handbags also get closed in this manner. Students, the materials having the property of attracting magnetic substances are known as magnets. The force exerted by the magnet on the magnetic substances is called magnetic force. Discovery of magnet. Students, there are different views about the discovery of magnet. One view is that there was a shepherd named Magnus. One day while moving on the mountainside along with his herd, he was surprised to find that nails of his shoes and the iron tip of his stick got stuck to the mountain rock. It was difficult for him to free his stick from the rock. At last, a wise man explained that the rock was a natural magnet and it attracted the iron tip of the shepherd's stick and nails in his shoes. This is how natural magnets were discovered. Type of magnets: natural magnets and artificial magnets. Natural magnets generally have low magnetic power. Moreover, such magnets are not found at all places. Therefore, artificial magnets are prepared by human which can be used at any time and at any place. These magnets are much stronger than natural magnets. Students, artificial magnets may be rod shape, U shape or horseshoe shape. Magnetic substances. Students, the substances that are attracted by the magnet are called magnetic substances. For example, iron, steel, nickel and cobalt. Non-magnetic substances. The substances that are not attracted by the magnet. For example, wood, stone, leather, plastic, aluminium and copper. Making a magnet. There are several methods of making magnets from iron pieces with the help of another magnets. The easiest way of making a permanent magnet is by the single touch method. Students, keep a steel bar on a table. Now take a strong permanent bar magnet and keep its one pole on the steel bar at end A. Without lifting the bar magnet, move it along the length of the steel bar till you reach the other end B. Now students, lift the magnet and bring the same pole to the same point on the steel bar from which you started. Strike the steel bar for about 30 to 40 times with the same pole and in the same direction. The steel bar has become a magnet. Properties of a magnet. First, attractive property. A magnet can attract magnetic substances towards it. This property is called attractive property of the magnet. Directive property. A freely suspended magnet always rotates pointing in the north-south direction. This property of a magnet is called its directive property. Students, the end of the magnet that points towards north is called the north pole of the magnet. The other end that points towards the south is called the south pole of the magnet. Usually students, the north and the south poles are marked on the magnet as N and S. Attraction and repulsion property. When the poles of two magnets are brought close to each other, they exert force on each other. Repulsion. The north pole of one magnet repels the north pole of other magnet. Similarly, the south pole of one magnet repels the south pole of another magnet. Attraction. The south pole of one magnet attracts the north pole of another magnet, and similarly the north pole of one magnet attracts the south pole of another magnet. Poles of magnet always exist in pairs. Take a magnet and break it into two pieces from the middle. The two pieces so obtained will have two poles, the north pole and the south pole, of their own. Now students, if you again break each of these pieces into two, you would again get two poles on each of the four pieces. If you continue breaking the magnet into smaller pieces, every piece of the magnet that you obtain will have both north and south poles. So, even the smallest piece of a magnet is a complete magnet in itself. This means that we can't isolate north pole or south pole of a magnet. The poles of a magnet always exist in pairs. We can also say that poles of a magnet are inseparable. Earth has magnet. The earth itself behaves like a huge bar magnet. The south pole of this bar magnet is near the geographic north pole, and the north pole of this bar magnet is near the geographic south pole. The north pole of a freely suspended magnet points towards the geographic north pole because it is attracted by the magnetic south pole of the earth. Students, similarly, the south pole of a freely suspended magnet points towards geographic south pole because it is attracted by the magnetic north pole of the earth. Magnetic compass. The magnetic compass is an instrument used to find directions. It consists of a small magnet in the form of a needle enclosed in a small box having a glass top. Students, the needle is free to move about its center. The base of the box is marked with directions like north, south, east, west, northeast, northwest, southeast, and southwest. Magnetic compass is of great use of travelers and navigators as it tells them the direction in which they are traveling. The magnetic compass works on the directive property of a magnet. The compass is kept at any place. Its needle indicates the north-south direction when it comes to rest. Demagnetization. A permanent magnet tends to lose its magnetism after some time if it is not stored properly. Magnets lose their properties if they are heated, hammered, or dropped from some height. Uses of magnets. Students, motors, generators, and loudspeakers have powerful magnets. In car yards, magnets are used to separate iron and the steel from junk materials. Data, sound, and image get stored on special surfaces coated with magnetic materials in hard disks, floppies, audio, and video tapes. Even students' information is stored on magnetic strip in credit cards, ATM cards, and air tickets. Magnetic compass, which is used by travelers and sailors to find directions.